1.
That's it.
There's no 4. You said. You guys had 4 in yours? Wrong section.
Five for section 16.
I'm already done with it.
Once you take the derivative, are you done?
Then you're done.
Okay.
So that's going to 0.
Okay.
Alright, let's go. This is number 1. Section 15. Okay, f of x is equal to 4x over x minus 2. Find the vertical and horizontal asymptotes. Piece of cake. Vertical asymptotes occur where the denominator is undefined. Where is it undefined?
2.
So x is equal to 2 is the vertical asymptote. Now, if I could cancel that off, it wouldn't be a vertical asymptote, it would be a removable discontinuity, which would be a hole in the graph. But I cannot cancel this off with anything on the top, so it's a vertical asymptote. Now the horizontal asymptote. Back in the day, okay, I told you you can use the ancient Indian secret. But now you cannot do that. You have to show me how to find the horizontal asymptote. Okay? To find the horizontal asymptote, you got to take a limit as x goes to positive infinity of 4x over x minus 2. I'm assuming we all know how to do that. You got to multiply top and bottom by 1 over x and do all that. But we can't jump to ancient Indian secret now. And what do you think that is going to be?
4.
Why? Because the powers, what? Are the same. I know, Jessica, that's why I said why. That's why I'm answering this. You gave me that baffled look that Michelle usually gives me. Now, powers are the same. If the powers are the same, it goes to the leading coefficient, which is 4 over 1. So, I also have to check, and that means I get y is equal to 4. That's one of my horizontal asymptotes. But I also have to check when x goes to negative infinity. It won't necessarily be the same, because if you remember tan inverse, it has 2 different horizontal asymptotes. So this is 4x over x minus 2. But in this situation, it turns out to be 4 also. So I have one horizontal asymptote, y is equal to 4. Yes.
If the powers were different, would it be...
Okay. If the power on the top is bigger than the power on the bottom, then it will not have a horizontal asymptote. It will either go to positive infinity or negative infinity.
Okay, and then if those weren't the same, it wouldn't have a horizontal asymptote?
Say that again?
Okay, if the powers aren't the same, it wouldn't have a horizontal asymptote, and then if...
No, I didn't say that.
Oh, you were talking about the limits?
Okay. If the power on the top is bigger than power on the bottom, it will not have a horizontal asymptote.
Okay.
If the powers are the same, you say if that's a square and that's a square, then the horizontal asymptote will be the leading coefficients, which will be 4. But if the power on the bottom is bigger than power on the top, it will always be 0.
Okay. And if the 2 limits are not the same, then there's no horizontal asymptote?
You mean here and here?
Yeah.
Now, no. Then if, let's say this went to 4 and this went to, let's say, hypothetically, let's say this went to 3, then you have 2 horizontal asymptotes. When you go to the left, it's going to go to 3. When you go to the right, it's going to go to 4.
Okay.
You could have 2. Okay, number 3. Alright, here we go. Okay, vertical asymptote. Okay, vertical asymptote occurs where the denominator is undefined. That can be factored to x plus 1 times x minus 1. So, what will turn the bottom into 0? 1 negative 1. So you have to write it separately. Don't write x is equal to plus or minus 1 because these are equations of lines. So x is equal to 1 and x is equal to negative 1. Cannot write plus or minus 1. These are horizontal lines. Okay. Horizontal asymptote occurs when you take a limit as x goes to positive infinity, and I have x over square root of x squared minus 1. Now this is going to be tricky, so you better know how to do this one. Okay? Now, then I'll show you the ancient Indian secret. What I have to do is I got to multiply this by 1 over x. What do I have to do in here is I got to multiply this by 1 over rad x squared. Because I got to get inside the radical. Got to take the highest power. Okay. The top one is 1. That's easy. The bottom, when I multiply this, I'm going to get a 1 minus 1 over x squared. Any questions? Yes, Jessica says.
Is that supposed to be x goes to infinity, or?
What's that? It's going to, oh, thank you very much. Holy cow, she is paying attention. There we go. Alright. Now, this is going to go to 0. If that goes to 0, the bottom's going to go where then? 1. And top's going to go to 1, so it's 1. So I have y is equal to 1 as my one of those horizontal asymptotes. Okay, now I have to check when x goes to negative infinity. X over square root of x squared minus 1. And I do like this problem.
Dang it. I was going to ask. You have to wait till I ask.
HB, just take some notes.
Is there only going to be one section?
Now all the questions come.
No, you can't use ancient Indian secret on this. Okay, here we go. Well, I will show you why I like this. As soon as Keith gets quiet. Alright. I like this because if I multiply top by 1 over x, and I multiply the bottom by 1 over square root of x squared, this is not 1 anymore. This is actually negative 1. The reason it's negative 1 is when I go to negative infinity, the top value will be a negative, the bottom value will be positive because I'm squaring and taking square root. So this is really a negative 1. I can't multiply something by negative 1 and not change the fraction. So I have to make an adjustment. This is positive 1. Everyone see that? That's a positive, that's another name for positive 1. That means I really did not change my fraction when I multiply. But this is really a negative 1. And if I multiply that, then I've changed my problem. So I have to adjust this. I got to turn this into positive by putting a negative right there. Okay? Now this whole thing is really a positive 1. Mathematically, I can do that. Okay, I'm going to pull the negative sign to the outside because we can do that in limits. And then I'm going to take a limit as x goes to negative infinity. Okay, on the top I'm going to get 1, on the bottom I'm going to get square root of a 1 minus 1 over x squared. Of course, This now goes to what? We figured that out in the last problem, goes to 1. But the negative sign will make that into a negative 1. And my horizontal asymptote here will be y is equal to negative 1. So how many horizontal asymptotes do I have? 2. And I have 2 vertical asymptotes. That is the work I want to see. What I'm showing you right here is what I want to see. I don't want to see the engineering sequence. But I will show you that now. Do I make myself perfectly clear?
Yes.
Okay. Really, when you look at this, the power on the top is 1, and when you isolate this, the power on the bottom is also 1, because square root of x squared is really x. So the powers are the same, so therefore it's going to go to the leading coefficient, which is 1. Now if it's a multiple choice question, you can just jump to that. Okay. And then this problem, the second half of that, when you go to negative infinity, okay? Okay, negative infinity, I'm still going to, powers are the same, I'm going to get 1, but because I'm going to a negative infinity, I know this value will become a big negative what? Number, and this value will always be a big positive number, so negative over positive is negative, so you get a negative 1. Okay, that's what you would do in terms of a multiple choice question. Okay, but if it's free response, you got to do what I'm telling you. So what do you want? AC now?
Yes, please.
Hey Ryan, do you know baseball stuff?
What's that?
Who do I tune into?
It says record. It's kind of wide though.
Hey Andrew, did you bring that?
Yeah.
When this one is on the test, we have to show all the all of that.
Everything I showed. Okay, section 15. 14.
Yeah, we just do every single one. 1,
Yeah.
How many of these are on the test?
Can you just leave that out?
1?
There's only one.
Alright, here we go. Number 1. SHB.
Sorry, but if there's only one, that's a bit redundant to do all 6 of those. Can you narrow it down to 3?
Heather, first of all, there's only 5 of these.
Sorry.